Alright, let's get to some real material with Unit 1 of Algebra 2, Number and Quantity. So the first thing that we've got to know is the number system. We have a real number system below, and the two main categories we'll need to know are the rational and irrational numbers. Inside rational numbers, we see here we have integers, and inside integers we have whole numbers, inside whole numbers we have natural or counting numbers. Rational numbers are essentially anything that has a decimal that terminates or repeats, while integers require that the numbers beyond the decimal point are zeros, for example, negative 3.00. Behind the decimal point, there's just absolutely nothing. Whole numbers have to be equal to 0 or greater, so no negative numbers, and natural numbers are equal to 1 and greater, so the numbers you could physically count on your fingers. We see here that this is kind of overlapping. These circles here in the rational number set are overlapping. What that means is that any natural number is a whole number, is also an integer, and is also a rational number, or any whole number is an integer and a rational number, but not a natural number. We can use this diagram to show what is what, and to classify the different categories. Now over here in a different circle we have the irrational numbers. Irrational numbers are simply numbers whose decimals do not repeat or terminate like pi or e. And next up we have some basic number properties. Alright, I'm not going to read through all of these, so you have to pause the video and write them down if you're taking notes, which is something we recommend doing. If you take notes, your brain will recall these concepts better on the exam, and you'll have a higher score than if you were just passively watching. Anyway, you'll need to know these properties of radicals, rational exponents, logs, and exponents for your exam. Now that we've got this set, let's take a look at some polynomial division. Polynomial division is just like regular long division, except you use two polynomials as your divisor and your dividend, and you'll get a polynomial as your quotient. And it's easiest to explain with an example. Let's say we're dividing over here 2x squared plus 7x plus 6, and we're dividing that by x plus 2. First, we're going to see what value we can multiply by this, by x plus 2, to cancel out one of these terms. And you usually want to cancel out the first term. So what could we multiply this by to cancel out 2x squared? So we'd want to have a negative 2x squared. Alright, so we're going to multiply x plus 2 by 2x, and we'll be able to cancel this out, because when we do long division, we want this to cancel out by subtracting. Alright, so we're going to take this, we're going to do 2x, we're going to multiply this by 2x, and we're going to get 2x squared plus 4x. We're going to subtract this, and we're going to get 3x plus 6 as our new polynomial. We're going to do this one more time. We're going to multiply x plus 2 by 3 to get rid of this 3x. And it just so happens that in this case, we got rid of the 6 as well, meaning there's no remainder. And in this case, a theorem called the factor theorem is going to apply right here. If there is no remainder, it means that x plus 2 is a factor of the polynomial. And in this case, it's really written as x minus a. So it's x minus a negative 2, not x plus 2, but obviously that's the same thing. Anyway, the remainder theorem, which is another theorem over here, will show what happens when we do have a remainder. Then the remainder will be f of a, or whatever we had left over, divided by the polynomial dividing. So let's say this was really like an 8 or a 5 or whatever. Right, it would be like say 3 or 2 over x plus 2 would be our remainder. Another note on this topic, you do not need to do synthetic division on the Algebra 2 Regents exam. And if you don't know what this is, don't worry about it. And if you do, you can use it and you are allowed to, but you do not have to by any means. So next thing we're going to talk about is rational functions. Rational functions basically look like fractions and operate like fractions, but with polynomials as their numerator, and their denominator. So as we see here, fraction rules are going to apply. And if you don't know your fraction rules, you should pause the video to take a look at these, the multiplication, division, or you can do a quick Google search. Now, on the topic of rational functions and fractions, we're going to jump over to rationalizing denominators. This is an extremely important topic that's probably going to make up like a question or two on your exam, and you're going to need this skill if you have a fraction with a square root on the bottom. See, we have a square root right here. So what we're going to do to rationalize a denominator is we're basically going to take the square root, we're going to get rid of it, and we're going to put it in the numerator. Alright, how we're going to do that is we're going to multiply both the top and the bottom by the conjugate of the denominator. Now what does this mean? A conjugate basically just switches the sign. So if we have b minus square root c, we're going to multiply by b plus square root c. And again, we're going to do this on the top and the bottom, because by fraction rules, if we multiply the same numerator and denominator by the same value, we're going to get an equivalent fraction. So in this case, if this was really b plus square root c, we would be multiplying by b minus square root c. And when we do this, we're going to eventually end up with something that looks like this. And as we can see, the square root is on the top and there is no square root in the bottom. Now we're going to quickly jump into factoring, and then we're going to move over into our last topic, which is complex numbers. Our first example is when we have a clear greatest common factor. We're just going to basically factor that out by taking the greatest common factor, as we see here. 5x and 3x squared have a common factor of x, so we're going to take that out. We're going to get x times 5 minus 3x. This is pretty much the most straightforward form of factoring you can get. Now, in example 2, we have a square number minus another square number, and we can rewrite this as the square root of the first plus square root of the second times square root of the first minus square root of the second. If that sounded a little complicated, let's take a look at this example. Our example shows that x squared minus 9, which is equal to 3 squared, is going to be equal to x plus 3 times x minus 3. And you can do the math here on your own to make sure this all checks out. Now, lastly, if neither of these are possible, or if you still need another example, you'll need to use the polyroots calculator function, which may be different depending on what calculator you're using, but you'll need to do that or figure it out yourself to find out two numbers that multiply to the c in this form ax squared plus bx plus c, and add to this b. Make sure you factored out any greatest common factors before doing this step, as we saw in example 1. So here's an example. We're going to need to find two numbers that add to -4 and multiply to 3. Now let's take a look at the list of things that multiply to 3. Well, 3 is a prime number, so that's going to be 1 and 3 and -1 and -3. Alright, now we see that when we add 1 and 3 we get +4, so that's not our answer, but when we add -1 and -3 we're going to get -4, so those are our factors, and this is the factored form of the expression. We can check our work here by doing a little bit of box multiplication, and if you want to take a look at this or do it yourself, we should get the original value, x squared minus 4x plus 3. And you may also need to factor by grouping, which is a new type of factoring that was probably not introduced to you in Algebra 1. This is most helpful when you have a polynomial or function with a degree of 3 or greater. Alright, you're going to need to make two groups with a greatest common factor, then you're going to have to factor out your greatest common factor, and then you're going to have to simplify. And here we have x cubed and 2x squared. Now we notice that here we have a greatest common factor of x squared, so we're going to factor that out and we get x plus 2 as basically what we just factored out. And then we're going to do this again with a greatest common factor of -3 for these two terms, and we're going to get -3 and x plus 2. Now if it is possible to factor by grouping, the things that are in these parentheses must be the same. And when you take this, you're going to rewrite this, you're going to put it over here, and then you're going to basically add these two things together. So x squared plus -3 is x squared minus 3. Make those into a factor and then multiply by these two by each other, and that is essentially how you would simplify this first equation here to a factored form. Now our last topic is complex numbers. Alright, we're going to go over here. Complex numbers. The imaginary I is the basis of the complex number system, and it is equal to the square root of -1. What that means is that I squared, when we square both sides of this equation, I squared is equal to just -1. And if you want to learn more about that, try looking at your curriculum again or Googling a little bit more of an in-depth summary. Again, this is just a quick unit review, so you should have already heard of this concept. Anyway, we have complex numbers which come in the form a plus bi, where a and b are both real numbers, and b is the coefficient of a set number of i's. Rationalizing a complex number is basically just the same as a normal one. You're going to multiply the top and the bottom by the conjugate. And we see here we have c plus di, so our conjugate is going to be c minus di. And again, we have to make sure that if we have basically a rational function in complex form, we are going to have to multiply both the top and the bottom by that conjugate.